Hi everyone, good day. Welcome to VSPARKZ. Today I am going to walk you through AWS Elastic Load Balancer, or simply you can call it as ELB. We are going to see a demo for the same. If you like this video, please subscribe to VSPARKZ channel. These are the contents of this video. We are going to see what is a load balancer generally, what is a elastic load balancer, that is ELB, its types and components of a load balancer. At last, we are going to see a demo for ELB. What is a load balancer first? Actually, a load balancer is a device that distributes the traffic across a cluster of servers. Now let us take the first case of accessing a website without a load balancer. Consider a website that is running in a web server machine. People or the users access these websites from their browsers. The flow is shown in the picture, I mean the first picture. So in this picture, only 4 people are accessing. What happens if the website is accessed by millions of people? The web server machine will go crashed whenever it reaches beyond its capacity. Let us take a look at the second picture with the load balancer. Here the role of the load balancer is to distribute the incoming traffic across a cluster of web server machines. Thereby it manages the incoming load. When you see the second picture, you can clearly understand that load balancer is a device, or it can be a service, that distributes the traffic, I mean the incoming traffic, to multiple servers at the back. Now let us take a look at Amazon's ELB. So ELB stands for Elastic Load Balancer. The Elastic Load Balancer distributes the incoming traffic across cluster of EC2 machines or Lambda functions or the IP addresses and so on. You can see the flow of a ELB in the picture. Now, types of Elastic Load Balancers. There are 3 types of load balancers available in AWS. First is the Application Load Balancer. It is also called as HTTP or HTTPS Load Balancer. When you are going to host a web application with HTTP or HTTPS traffic, you can choose this Application Load Balancer. Second is Network Load Balancer. When you are going to access your applications at the TCP connection layer, you have to pick Network Load Balancer. Network Load Balancer supports TCP, UDP and TLS protocols. Whereas the third one is the previous generation load balancer or the classical load balancer. Let us explore the components of a ELB. So this Elastic Load Balancer is basically classified into front-end portion which receives the traffic and the back-end portion which serves the traffic. Here the front-end portion is nothing but the listener. A listener is a process that checks for the incoming connection request using the protocol and the port that you configure. Whereas the back-end portion is nothing but your target group. The target group is used to route the requests to one or more targets. Here I refer the targets as EC2 machines, or it can be Lambda functions, or it can be the IP addresses. One target group can have multiple targets. At last, health check service is used to check the health of the targets. If the targets are not responsive, they will not participate in load balancing. This is possible only with the help of health checks. Now let us explore the architecture of a ELB, I mean the elastic load balancer. This is the exact architecture of a ELB. You can see a rule in the picture, right? So the rule that you define for the listeners determine how the load balancer route the request to the targets in one or more target group. You can have multiple target groups in a load balancer at the backend. Host-based rules and path-based rules are some of the rules that we should mention here. Now we will see the demo of load balancer. Here are the things that we are going to do in this demo. Let us do this hands-on, step by step. We'll go to the first step. So here we are going to create two targets, I mean the EC2 VMs in the AWS VPC, that too in different subnets we are going to create. Here targets I refer to as EC2 machines. Just open your AWS management console, go to services and click EC2 and launch a EC2 instance. For this demo, you pick up Amazon Linux. Machine class, I am going to choose it as T2 micro. Network is going to be the default network. The subnet, you choose any one of the zone. Add your storage, security groups. Here just open the port which is needed for your application. So for time being, I am allowing all the ports to communicate outside. So here I am creating a new security group and I am allowing all the traffic, and the source as anywhere, means from anywhere across this globe you can connect this particular machine. Now my machine got launched. Just give a tag for your machine. Let us assume it as a first machine. So it's time to launch the second machine, but this time you are going to launch this machine in a different subnet. Now why? Because your target group must contain machines from different subnets or zones, just to ensure high availability concept here. So I'm going to launch my second machine. That's it. My second machine got launched. For easy identification, tag this machine as well. Let us assume this as a second machine. So now we are going to connect these two machines in the client. The client which I am going to use to connect the Linux machines is MobaXterm. You can get this MobaXterm client for free from the MobaXterm website. So this is my client. Just click sessions, SSH, copy paste the public IP address of that particular machine, specify username. The username you can get it from the console. Just say connect and you can see EC2-user there. That is the username for your machine. Just include the username. Go to advanced SSH settings, include your private key. So in our case, Mumbai.pem is the for my EC2 machine. That's it. I just connected to my EC2 machine. For easy identification, just rename your tab. I am saying first machine. So similarly, try to connect your second machine. Put again sessions SSH. Include your public IP address of your second machine. Specify username. Username is going to be the same because we used the same Linux image. My second machine got connected. So again rename the particular tab for easy identification. That's it. So our first step is done. So our second step is going to be deploy web servers in the targets. So in this video we are going to use Apache HTTP web server. So to install Apache web server, we need to log in to the Linux machine as a super user, I mean the root user. So the command to install Apache web server is yum install httpd. If you want to search a particular package, just type yum search the particular package name. Now it's time to install the web server. Just say yum install httpd. It will ask you for a confirmation. Just say yes. Your web server will get installed. Now we are going to deploy the HTML web pages. So just go into this path cd var www html. Create a new index file called index.html in that particular path and copy your HTML code there. Now start the web services. Now my HTTP service is started and it is running. Go to your browser. Just take your public IP address of the first machine and paste it in your browser. You can get the web page. Whatever we configured in the first machine, we'll be getting it. Similarly, try to configure the same procedure in the second machine. The only change that you are going to do here is you are not going to deploy the same web page in the second machine, but a different web page you can deploy here. The reason why we are deploying a different one is that then only we can test the functionality of a load balancer, whether the load balancer is distributing the traffic from first machine to second machine or second machine to first machine. Like that we can conclude. For that case, I have removed the third line and I edited it as second machine. So now my web server, its services got launched and running. Again, test the same for your second machine, whether your configured web page is displaying or not. Yeah, I came to know that the second machine's web pages are working. And this is the third step. So we are going to create a target group and we are going to register the targets. So you remember the target group is the backend of your load balancer. You can also create the target group on the fly, but for your understanding I am just creating it separately. So the target group name is my target. The target type is instance because I am going to register the EC2 instances at the back. The protocol, you choose it as HTTP. Now I am configuring the health check parameters. Healthy threshold value, you reduce it as 2 and the interval as 10. Why? Because then only your instances will get registered as quick as possible. Just go to targets and register your instances. Just say add to register. Now these two instances got registered to the target group, but it is unused because this target group is not attached to any of the load balancers. Now our fourth step is to create a load balancer. Configure listener, target groups and the health checks. So just go to the inventory, click load balancers, create load balancer. The load balancer which I am going to choose is application load balancer because my application at the back of my instance is a HTTP application. So just give a name for your load balancer, and the scheme you have to pick it up internet load balancer. Configure your listener here. The next step, specify your availability zones. For time being I am choosing all the availability zones, even though we don't have any instance in the last zone, I mean the AP South 1C zone. The next step, configure your security groups for your load balancer. Here I am allowing all the traffic. And next is configure routing. Here you have to choose your target group, which is your existing target group. If you want to create a new target group, you can create on the fly. So these are the two instances that is at the back of this target group. Just review your page and just say create. So now your load balancer got created. It will take some time for your load balancer to become active. Now it is provisioning. You can see your target groups instances. It is in the initial stage, which means target registration is in progress. Health check is checking these instances whether these instances are responding or not. Once the health check has done, you can see the instances becomes healthy. Now you go to your load balancer, you can see the status of your load balancer as active. Now it's time to test your load balancer. Now the DNS name is elb.aws.amazon.com. that is the thing which I was representing in the picture, but in the real time the DNS name is elb-207 blah 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 something. Okay, just copy the DNS name. If you want a meaningful name, just manage this load balancer's name in your domain management system so that you can get a meaningful name. Now copy and paste the DNS name in your browser. You can see it is hitting your first machine at the back of this load balancer. So try to refresh this page. You can see the load balancer is hitting different machines on each and every refresh, which means the load balancer is distributing the incoming traffic to different machines. That is the job of a load balancer. Now we came to know that our load balancer is working perfectly. So once you are done with your lab, just clean all the resources from your console, otherwise you may be charged. So just delete your target groups, delete your load balancers as well as your EC2 instances. So with this we are completing this demo. This is the summary of our video. We have seen what is load balancer, what is an elastic load balancer, its types, components, and at last we have seen a demo for a AWS elastic load balancer. If you like this video, please subscribe to VSPARKZ channel. Thank you from VSPARKZ.com. Thank you for spending your valuable time in seeing this video. Have a nice day.